Today's lesson is lesson 3 on dependent and independent events. So if you think about something being dependent versus independent, you might use it in terms of somebody is dependent on a different person, meaning that they rely on them too much, or maybe they just need them. Whereas independent, if you are independent, it means you do things by yourself and it's not affected by others. So when we're working with probability, it's going to be similar. So let's look at these two situations here involving a deck of cards. So the first situation, it says drawing two cards from a deck without replacement. And you'll notice that word without is in red. So that means I take a card out and I don't put it back in. So I draw one card and I don't put it back in, and then I draw another card. So the two events are described. A, the first card is a spade, and B, the second card is a spade. So let's answer these questions here. It says, how many cards were in the deck on the first draw? So when we drew the first time, just like any deck, we would have 52 cards in that deck. How many of these cards were spades? So remember, spades are a quarter of the deck, which is 13 cards. So if all 52 cards were there, 13 of them would be spades. Okay, so now we have our first event finished and we have to do our second event, which is the second card is a spade. However, I didn't replace that first card. So now there's only 51 cards in the deck. And I assume that I got my favorable event in that first draw, which means now there's only 12 spades left in the deck. So now if I wanted to calculate the probability of A and B drawing a first card of spade and the second card of spade, I would consider that that word and means multiply. So I am going to take the probability of A, probability of drawing my first spade, which is 13 out of 52, and multiply it by probability of B. But now my probability of B is 12 out of 51 because I have taken a card out of the deck. So I would go ahead, type that in on my calculator, and I would get the answer of 1 over 17. So I have a 1 in 17 chance of getting two spades. So these are what we call dependent events. The reason they are dependent is because the outcome of the second event depended on what happened in that first event. The reason that this was dependent is because we did not replace the card. So now let's zone in on situation 2. So in situation 2, it's the same idea. However, now it says with replacement. So I take the card out, but then I put it back in. Now this is a very different type of situation. So how many cards were there in a deck on the first draw? There were 52, and out of those, 13 were spades. How many cards were on the second draw? So we take that spade out and now we put it back in. So there are still 52 cards. 13 of them are spades. Okay, the word and still means multiply. So we are going to multiply my probabilities, but now it's just 13 out of 52 multiplied by 13 out of 52. Okay, if I multiply those on my calculator, I will get 1 out of 16. So this is slightly more likely to happen than my first situation, 1 out of 16 compared to 1 out of 17. So these are what we call independent events. The reason they're independent is because the outcome did not change based off of what happened in my first event. So we have formulas for this. My formula for dependent events and independent events. If the occurrence of A does not affect the probability that event B occurs, then A and B are independent events. Okay, so let me draw an arrow here. That's this situation. Situation 2. Notice our set theory notation, probability of A and B, and then we multiply our probability of A times probability of B. So for both of these formulas, we end up multiplying. The difference lies with this symbol here. So it says, if the occurrence of event A affects the probability that event B occurs, then events A and B are dependent. Okay, so here's A and B again, but now it's the probability A times the probability of B given that A has already happened. Let me write what that means here. The second one here is the probability of B given that A has already happened. So you'll notice that in the example we just did, that the probability of B, given that A has already happened, it changed because our events depended on what happened in that first event. Okay, so this is our independent and this is our dependent. Let me just change some coloring here. So we're going to use this idea to solve problems involving either dependent and independent events. Notice that all of these happen at the same time, right? It's A and B, not A or B. So this is a very similar idea to our last unit when we consider it, because it means we're going to be multiplying. Just a reminder, both of these formulas are on your formula sheet. Okay, so our first goal is to be able to identify whether an event is independent or dependent. So let's check these out. It says tossing heads on a coin toss and rolling 6 on a die. Always ask yourself, does tossing a coin affect my outcome of rolling a die? And the answer is no. And that means that these are going to be independent events. They do not depend on each other. Okay, next one. On a deck of 52 cards, 2 cards are drawn without replacing the first one. So as soon as you are not replacing, those are going to be dependent. Okay, the second one says out of a deck of 52 cards, the first card drawn is a king, and after replacement, the second card drawn is a queen. Now we've replaced the cards, we are no longer affecting the outcome of event B. So those are independents. Okay, the next one says a bag contains 10 candies, which are 3 different colors. Probability that Joe picks a red one, then eats it, and then the probability that Sue picks a blue one. So because he is taking that candy out and eating it, that is similar to not replacing the card. That is dependent because Sue's probability has changed based off of what Joe has done. Let's try a few examples. So these two examples are very closely related. The first one is talking about drawing something with replacement, and the second one is drawing something without replacement. First, we're replacing the cards. So it says 2 cards are drawn with replacement from a shuffle deck of 52 cards. Let A and B represent these events. A, the first card is a 7. B, the second card is a 7. So what is the probability of A? Probability of A is equal to 4 out of 52. 4 of the cards are 7, and there are a total of 52 cards in a deck. We can simplify that to 1 out of 13. Okay, probability of B. So now we've taken the card out, but we put it back in, so it is still 4 out of 52, which is equal to 1 over 13. So for the probability of A and B, we take those two probabilities and we multiply them. Okay, for multiplying fractions, we multiply the tops together and multiply the bottoms together. You can also type this in on your calculator, but please convert it back to a fraction. Otherwise, you have to worry about rounding. Okay, the next one is very similar, but now it says without replacement. So we take that first 7 out, and then we don't replace it. So the probability of A has not changed. It is still 1 out of 13. That is the simplified version of 4 out of 52. However, B, the probability of B, given that A has already happened, we now only have 3 sevens in the deck and only 51 cards. So 3 out of 51. So to find the probability of A and B, we would take those numbers and multiply. A on my calculator, that simplifies. Remember, math frac, 1 over 221. Okay, so once again, these here are dependent. Meaning that the probability of B has changed because of what happened in A. Okay, we're going to do a similar type question now with cards. It says 2 cards are drawn with replacement. Is key from a shuffled deck of 52 cards. What is the probability of drawing a King of Hearts and the Ace of Hearts? Okay, so there are my two events, the King of Hearts. King of Hearts, there are only one King of Hearts in a deck of cards out of 52. So there's a 1 out of 52 chance of getting the King of Hearts. And then it says the second card is the Ace of Hearts. There's only one of those as well, so 1 out of 52. Remember that these are independent, meaning that the outcome of event B did not change based off of what happened in A. So now I go ahead, I take those and I multiply 1 out of 52 times 1 out of 52. And I get 1 over 2,704. The second question is the same with that slight change up. Now it says no replacement. So how would that affect our probability? The first probability would not be affected. It would still be 1 out of 52 for how many King of Hearts there are. The second probability doesn't change our favorable outcome. Our favorable outcome is still 1. However, there are only 51 cards in the deck. So I now take those two probabilities and I multiply them together to get 1 over 2652. 1 and 2,600. So once again, these are dependent events because the outcome of B changed depending on what happened in A. All right, next page. In one bag, there is 2 green balls and 4 white balls. In the second bag, there are 3 green balls and 2 white balls. 1 ball is drawn from each bag. What is the probability of drawing 2 white balls? So a little bit of notation here. Our probability, we are looking for a white ball and another white ball. That would help me decipher what operation to use. Means I'm going to be multiplying. So now I look at this and I determine, is it an independent or dependent event? As they are separate bags, it is going to be independent, meaning that the probability of my second white ball isn't going to change. So in the first bag, I have a 4 out of 6 chances of getting a white ball. And in the second bag, I have 2 out of 5 chances of getting a white ball. Multiply those together, we get 8 out of 30. 4 times 2, 6 times 5, and that simplifies to 4 out of 15. So there's a 4 out of 15 chance that we will get 2 white balls. Okay, let's try the next one. In one bag, there are 2 white balls and 3 yellow bags. In this In the second bag, there are 2 green balls and 1 orange ball. One ball is drawn from each bag. What is the probability of drawing 1 white ball and 1 green ball? So we are looking for the probability of a white and a green ball. Once again, these are 2 separate bags, so they are going to be independent events. So the probability of a white ball for the first bag is 2 out of 5. The probability for a green ball is 2 out of 3. I accidentally put a plus sign in there. And means multiply. So that gives me 4 out of 15 as my probability of having 1 white ball and 1 green ball. All right, last example here. It says the probability that Ashley will pass math this semester is 0.7, and the probability that she will pass English this semester is 0.9. If these events are independent, what is the probability that she will pass math and English? So our notation would look like this. Probability that she will pass math and English. Means because they're independent that we will take the probability that she will pass math and multiply it by the probability that she will pass English. Remember that probability can be written as decimals. So here we have the decimal form. So probability she will pass math is 0.7. And we are going to multiply that by the probability she will pass English. Okay, when I multiply those together, I get 0.63. So there's a 63% chance that she passes both math and English because they are independent events. All right, go ahead and give the your turn a try. Pause the video, and then when you are ready, you can unpause the video to show the answer.